Very good morning. Today we are going to discuss about isometric projection. So far we discussed about a projection of planes, a projection of solids, and today we are going to discuss a somewhat a different from projection of solids or projection of planes. So this isometric projection is completely different from a projection of solids and projection of planes. So in projection of solids and planes, at a time we can able to see only a top view or only a front view or only a either right or left side views. But in this isometric projection, in a single view, we can able to see a top, a side as well as a front. In all the three views, we can see in a one particular view. That view is called isometric view, and the projection of that view is called isometric projection. So isometric drawing is a type of a pictorial projection in which all the three dimensions, that is most important, in which all the three dimensions of the objects are shown in one view. And if it required, okay, if you want to see all the three views in a one particular view, means we can go with the isometric. No, I want only particular top view, particular front view, particular side view, means you can go with the orthographic projection of solids as well as orthographic projection of planes. In that you will get a top view separate, a front view separate, a side view is separate. But here in isometric, all the three views, that is what a three-dimensional, this view is also called as a three-dimensional view. So you can able to see all the three views in a one particular position or a view, and that type of projection is called as isometric projection. And here their actual size can be measured directly from it. Means in the isometric projection, so the actual dimensions is vary. So in the top view and in the front view and the side view of projection of solids and projection of planes, you get the actual position, actual size and dimensions. But here we have to go with the isometric projection, means isometric scale. We have to follow a one particular a separate scale is called isometric scale. See this picture, the figure 1 shows that a isometric scale or isometric length and a true length or true scale. So you just see this is what the horizontal line, okay, and here just a minute. Okay, say this is what a isometric, and this isometric always it is of 30 degree, and this is a true length. So in the true length, if it is 1 centimeter, means in the true length it is the same 1 centimeter. 2 centimeter it is written 2 centimeter, 3 centimeter 3 centimeter. So like this in the true length is that is what actual scale length. But in the isometric it is not so. If it is a 1 centimeter, means the isometric 1 centimeter it is always less than the actual 1 centimeter. Actual 1 centimeter which is equal to 1 centimeter is equal to actual 1 centimeter which is equal to 0.813 isometric length. Okay, say you just draw a 30 degree line, take a horizontal line, okay, AB is the horizontal line, and draw 30 degree line. So this 30 degree line represents the isometric projection. Always isometric projections drawn on 30 degree. So 30 degree represents an isometric view. Okay. So if you draw any particular view in 30 degree, that will become a isometric. So 45 degree is the actual one, or horizontal or 45 degree or 90 degree, it gives the actual line length dimensions. But 30 degree it is not so. So first draw a horizontal line like this and draw 45 degree, okay, and mark on this 45 degree a 1 centimeter, 2 centimeter, 3, 4, 5, 6 like this, okay, it's a true length. And next draw 30 degree, okay, draw 30 degree line, okay, and project that one a centimeter to from 45 degree to the 30 degree. Okay, so project this. Next project this 2 centimeter to 30 degree. Next project this and project 4 centimeter, project 5 centimeter, project 6 centimeter. So like this it goes on, and if you measure the actual length, so the actual length of this 30 degree, okay, actual length of this 45 degree, it is projected on 30 degree line, means that is what isometric. This dimension is reduces. In actual it is 1 centimeter, okay, actual it is a 1 centimeter. So that 1 centimeter is equal to here 0.81, okay, so it is 0.81. But here 1 centimeter is equal to 10 mm, but in the isometric, the 1 isometric centimeter, which is equal to 8.13 mm, means it reduces its dimension. So that is what isometric length. And you just observe a one rectangular slab, okay, or a square slab is there, and that square slab, okay, I am going to draw it on the isometric. So if you want to draw it on the isometric, you have to construct that into the 30 degree line. First you have to draw a horizontal line and mark the 30 degree line. Then you are going to construct, or you are going to represent your rectangular or square slab onto that 30 degree, so that it will give, see here I can able to see the top view, I can able to see the front view, I can able to see the side view. So in a one single view I can see all the three views, top view, front view and side view. That's why this is called as isometric view. Okay, and always isometric view, it is drawn on 30 degree. 30 degree represents isometric projection. So next, some of the definitions. Isometric scale. So isometric scale, it is the scale in which it is used to convert the true length into isometric length. So in isometric scale, we are going to convert a true length into isometric length. If it is in the front view, it gives a true length. If it is in isometric view, it gives the isometric length. That isometric length we should convert. 1 mm is equal to 0.815 mm, okay, or 1 centimeter is equal to 0.815 centimeter. That is what reduction. A normal 1 mm, which is equal to isometric, it is 0.815. Okay, so it is 10 mm. In isometric, it is 8.15 mm. Like this, we have to convert. Clear? Next, isometric axis. So isometric axis is a point C. You see, a point C and a point G in the figure 2. This is a figure 2. A point C and point G here. So point C and point G in the figure 2 are called isometric axis. Okay, the point at which making an angle 30 degree, means at that point. So this is a point, at point G it will make an angle 30 degree. It will draw the angle 30 degree. So this a point, okay, in which we are going to draw a line. That line is, we can call it as a isometric axis. It is always perpendicular. It is always vertical. Okay, it's a vertical line. Either you can consider 30 degree, or from here it is 120 degree, means inside. From here to here it is 120 degree, or outside 30 degree, outside 30 degree. So it completes 180 degree. Okay, so BC is a one line, and CD is another line, and FG and GH. Okay, so these are all lines we drawn from this point G, and this gives the isometric axis. So next is isometric line, the line which are parallel to the axis are called isometric lines. A line AB and AD. A line AB, AD, okay, they are parallel. The line AB and AD and F E, F E, E H, F B and HD and EA. So all these lines what we drawn from this point G, that is with respect to the 30-degree line. So these lines we can call it as a isometric lines. Then isometric plane, the plane, okay, represents the face of the object. So this is what the face of the object. This is what the face of the object. This is the front face, top face, side face. Okay, the plane representing the face of the object and which are parallel to the isometric axis. Means ABCD. This is ABCD, EFGH. So these are the two faces, okay, which are parallel to the isometric axis. That's why it is called isometric planes. So these are the some definitions: isometric scale, isometric axis, isometric line, and isometric plane. Okay. So here everything we drawn it in the isometric. We are not using any normal scale. And one more thing is, so in this isometric, so there are two important point you have to remember. That is what, see here. If you draw isometric view, okay. So these are the two sheets. One is normal sheet and another one is isometric sheet. So normal sheet you can able to see here. So this normal sheet what we are generally using for construction of projection of planes, projection of solids, okay, points, lines, what we are using this normal sheet to construct, because here 1 unit is equal to 10 mm, means 1 centimeter. 1 unit is equal to 1 centimeter, which is equal to 10 mm. It is a normal scale. But second one is what I am showing is, this is an isometric sheet. So here normal, a perpendicular and horizontal, only a perpendicular horizontal line. But here it is isometric sheet. Isometric sheet is completely different from normal. Okay. So here you just measure this, the inclination. All these boxes are inclined and this inclination is, okay, 30 degree. If you measure, this gives the 30 degree, this gives the 30 degree. So 30 degree means isometric. So all these units are inclined to 30 degree, means that represents the isometric sheets. So you are going to construct isometric object in isometric sheet. So if you are constructing in isometric sheet, there is no need to conversion, because already these blocks are converted. You just observe the scale. 1 unit is equal to 8.164 mm, 165 or 164. Okay. So here 1 unit is equal to 10 mm, here 1 unit is equal to 8.164 mm, means it reduces to isometric. So here no need to convert. First you can draw object in a normal scale, then directly draw it into the isometric sheet. So in isometric sheet you no need to convert, because already that sheet is converted to isometric. So you can directly draw here 50 mm, so 5 blocks. Okay. So 50 mm length is there. Here if you want to construct 50 mm, you just take the 5 blocks. Okay. That gives the 50 mm. If you measure this, it will give the isometric length. It is around 40. Clear? But if you draw it in the empty sheets, unruled, then you are going to convert. You are going to convert normal scale into isometric, then you have to construct the isometric, because here there is no sheets. So this is what the normal unruled sheet. Okay. So then you have to draw a 30 degree line, then convert a normal length into isometric, then you can construct. But in isometric sheet no need to convert, because already that sheet is converted to isometric. Clear? Okay. So this is the one important point you should remember. Yes. In general, so the construction, come to the construction. The construction of isometric, we generally go with a box method. We generally go with a box method. It's an easy one, easy method, and easy to construct, and also easy to understand. So by using this box method, we are going to construct a normal object into isometric object. So in this method, the object is assumed to be enclosed in a rectangular box. Means any object, if you take any object, pentagon, hexagon, circle, or a normal rectangle, or a triangle, so whatever the box, whatever the profile, so whatever the profile or whatever the design, that design is enclosed in rectangular box. That's why it is become a box method. And both the isometric and non-isometric lines are drawn by locating the corresponding points of a contact with the surface and edge of the box. With the help of this box, okay, we are going to construct all the lines, points, corresponding lines and points we are going to draw, and we are going to close that drawing. The box method is generally convenient for solving the problem. That's why we are going with the box method. See, the first I will explain some of the simple shapes, how we are converting from normal shape to isometric scale or isometric drawing. So this one is the first one. Okay, so here first one, isometric view of 40 mm square. So here you just observe, I constructed these in unruled sheet, not isometric sheet. If I used isometric sheet, there is no need to convert, but I used in unruled sheet, normal empty sheet, so that we need to convert. So here 40 mm means normal scale. In isometric, 40 means it is 32.64. It is 32.64. That's why either you can call 40 mm iso. If I call 40 mm iso means it's a isometric 40 mm. So isometric 40 mm, which is equal to 32.64. You just multiply 40 into 0.815. It gives the 32.64. So in the normal scale 40 is there. In isometric it reduces to 32.64. Clear? And here also same. First draw a square 40 mm. You know that how to construct. First draw a one vertical line 40 mm. Then draw a horizontal line 40 mm. Then parallel to this vertical and parallel to horizontal, join this and name it as A, B, C, D. So A, B, C, D is, this is what a normal square. This square I want to construct as a isometric. Then this is a top view. This gives a top view of isometric, and this is a front view of isometric. Clear? A top view and front view. So first there are only two views, so top view and front view, and by using this top and front view, corresponding view we can easily generate. So see here 40 mm we already constructed. Next what you have to do is take a horizontal line, okay, then draw 30 degree with the help of your protractor, mark 30 degree and draw 30 degree line. Next what you have to do is take this 40 mm, convert to iso. So 40 mm, how you are going to convert means 40 into 0.815 or 0.8164. So whichever is convenient. So take that, multiply, and that gives 32.64. And take that 32.64 from your compass and mark here up to here. Similarly, mark here, so that you will get a two lines. That is what A is here, and you got a B point, you got a D point. Next I need a C point. So here no need to use compass, you just use a scale parallel to this AD. Parallel to this AD, draw a one more parallel line which intersect B. Draw a parallel line which is parallel to AD. So this we can done with the help of rollers. You can use the rollers. So first roller placed on a AD, then move the roller up to B point and draw a line. So this line is parallel to this. Next similarly, so place the same roller or a scale on AB and move towards up to point D and then draw a line. Clear? And this parallel line which intersect the another parallel line, and you can name it as C. Clear? So this way you will get the box. So here square is the shape, so square is the box. So like this you have to construct top view. Similarly for the front view, first you just draw a vertical line, okay, that point is A, and draw D point, vertical, and it is of 40 mm. We already know that it is a 40 mm. 40 iso means 32.64. Next from point A, draw a 30-degree line, 30 degree, okay, that is what isometric. If it is not 30, it is not isometric view. If it is 30, then only it is become a isometric. So after drawing 2, this we can call it as a B. And similarly same, use the roller or a scale parallel to this AD, move the roller up to point B, then draw one more line, vertical line, or use the roller. Next same, place the AB roller or a scale and move towards point D and placed up to point D, then draw a line. Clear? And you will got a point C. Intersection of these two parallels, you will got an intersection point that we can call it as a C. So this gives the a front view of square. So like this you have to construct top and front view. So 40 mm means normal, isometric it is 32.64. Clear? Yes, I will show you how to construct this isometric view of 30 mm pentagon. Okay, for this I have one yes, see, first you have to construct the pentagon in a normal pentagon with a if you are constructing in an unruled sheet or a normal sheet, then you use a ISO 30. Okay, ISO 30 means it is less than 30 mm. So draw pentagon with a this dimension, normal dimension. Okay, then for a construction of this pentagon, first draw a horizontal line. That is the most important. You have to draw horizontal line, then draw 30-degree lines. So mark this is 30 degree, and here also same 30 degree. Okay. Yes, next thing, just measure. Okay, so you have to mark 1, 2, 3. Okay, box. So that is what a box. This pentagon is enclosed in a box. That's why it is called as a box method. So here you better mark 1, 2, 3, and 4, and measure 1 to 2 from here 1 to 2 measure. Okay, and measure from here with the help of compass and mark it. Similarly, from 2 to 4 you just measure, and from here you just draw or cut the arc. Like this, first you have to construct the box 1, 2, 3, 4. That box first you have to construct. This is a 2, sorry, this is a 4 actually. This is 1, 2, 3, and 4. So this is a 1, and this is a 4, and this is a 2. And by drawing the parallel, you just got the intersection 3. Okay, and remove unwanted extra projections. Okay. Once the box is completed, construction of box, then you have to mark the points A, B. So AB is in 1, 2 line. So in this 1, 2 line there is a AB point, and in 2 to 3 line there is a point C, and 3 to 4 there is a point D, and 4 to 1 there is a point E. Like this you have to construct all the points. You have to mark all the points. Yes, from here you have to cut this. Yes, this, and here with the help of the compass or with the help of scale you just mark that and draw that. So that gives the A point. This is A, and this is B. Like this you have to mark. and make it a thick visible line, A and B. Similarly, you have to mark a C here with the help of scale, measure the dimension and mark here. That point is C. Similarly, exactly middle, you just mark D, and parallel to this C, you just mark the E point. So like this, you have to mark all the points, and finally, with the help of a scale, you have to join A to B, B to C, C to D, D to E, E to A. Like this, you have to construct. So that gives a top view of a pentagon. Like this, you have to mark and join. So that gives the front view. So that is what ISO 30 mm. So like this, you have to write. And I will show you how to construct hexagon. Okay. So how to construct, just only I shown how to construct pentagon in manually, and here I will show you how to construct hexagon with the help of software. Okay. First you have to construct the hexagon. See here, 30 mm, let us take 30 mm. So I already explained you how to construct. So either with the help of circle, you just go better circle method. Okay. So circle diameter is 60. Okay. Next, so here you take the arc or take the compass and make it 30 as a side, cut the arc. Similarly, cut the arc. Okay. Like this, you have to cut the arc, then join all the points. So like this, you have to construct the hexagon. After constructing, better to remove that. Then you just enclosed this hexagon in a box with the help of scale. Okay, with the help of scale, enclosed. Use the scale and pencil, enclose this. In the software, use the line command. Like this, you have to enclosed, and you just name it this as a 1, 2, 3 and 4, and you can call it as A, this is B, this is C, this is D, E and F. Here all these. Okay, so I constructed hexagon, and this is of 30 mm, normal 30 mm. So I want to construct hexagon in a unruled. This is just remember, this is an unruled sheet, so that I have to convert this. So means select this and go to the scaling, and it is of scale, I reduced to the isometric scale. Now you just measure, yes. So normal 30 mm, which is equal to ISO 30 means 24.6. If I say ISO 30 means it is 24.6. Now all the dimensions are converted to ISO. Now you can go to construction. First draw a horizontal line. Okay, so like this. Then use the same. So I'm going to place here a 1 point. Okay, so here and draw 30. Sorry, the angle is 30. Length we don't know. Okay, somewhat extend. Next, similarly, this is 150. Okay, we don't know the angle. So next is measure this. So from here to here, what is the distance you have to measure? Okay, so it is 42.61. So from here, okay, so take the arc placed here, means take your compass, measure from 1 to 2. So it is 42.61 isometric length. So 42.61, cut the arc. Similarly, so this length, I think this length, it is of 49.2. So again take the same arc, 49.2, and cut the one more arc. So like this you have to cut the arc and erase the unwanted thing. Then use the line and draw a parallel. See, so for this it is parallel. Okay. Similarly, draw the line which is parallel to this. So now it is parallel. So like this you have to draw the line, that is with the help of either scale or roller, and after that you remove the extra projections, and you can name it as this as a 1, and this as a 2, this is 3, and this is 4. So like this you can construct manually. Okay. After this you have to place the point A. 1 to 2 there is a point A, 2 to 3 there is a point B and C, 3 to 4 there is a point D, and similarly 4 to 1 there is a point E and F. So those points you have to place it. So that is with the help of this dimension. Okay, so this dimension is, so these dimensions you should measure. Okay, so with the help of these dimensions you can draw the lines. So take the line. Okay, so or else you can take the arc. So placed on 1. Okay, and the dimension is 21.3 is there. Okay, and cut the arc, you will get a point A. You can call it as a point A. Similarly, 2 to 3 there is a 2 points. Okay, use the same compass, so placed it here. Okay, and the dimension is 2.3, means placed it 2 and stretch up to B. Okay, cut the arc. So here also same thing, it's the same, 12.3 is there, and cut the one more arc. Okay, and you can call it as a, this point is a B and this point is a C. And similarly with respect to A there is a one more point which is parallel. Okay, so it's a parallel line. Either you can use the scale. Okay, either you can use the scale to construct this. Okay, like this you can join. So it should be a parallel line. Draw with the help of a roller. Once we got the point C and B which are parallel. Okay, and you can name it as, this point is 1 to 4. Okay, so it is a F and it is a E and it is G. See, only in case of this hexagon, but in the case of pentagon you will get a different points. So here C and E is same, okay, they are parallel. F and B are parallel, A and D are parallel, but in case of pentagon A, B, C, D, E all are different. So now use this line, okay, then join from A to B, B to C, C to D, D to E, E to F, F to A. See, like this you have to construct. With the help of scale you can join. See, this is what the isometric view of 30 mm hexagon. Okay. So this is a one method. Another method is there. So in case of software, okay. So first you just construct hexagon. Okay, like this you can construct the hexagon. And so this is a normal hexagon, okay. So you construct as it is with a normal dimension, okay, like this. Then with the help of scale you can reduce to isometric. That is another method, okay. First draw as it is normal dimension, then convert, or first convert and construct, then draw. So whichever one is convenient you can go with that. So I will show you. So hexagon first, 30 mm, 0, 30, 60, 30, 60 into 2, 30, 60 into 3, 30, 60 into 4, 30, 60 into 5. Okay. So like this first you construct a 30 mm hexagon, okay, and draw the box. Box is compulsory. So because we are following the box method. With the help of scale, okay. So like this you draw the box. I name it as so this is 1, this is 2, this is 3, this is 4, and you can call it as A, B, C, D, E and F. So like this you construct. Then, okay, so as it is you construct first, it's of like this you just construct, okay. So then measure this distance. So like this you have to measure. So first 60 and 51 points. So one is here. So use the line or a compass. So from here 60, cut the arc and placed here, and it is of 51.96. Okay, cut the another arc. Then draw the parallel line, which is parallel like this, and you will get an intersection point. okay, and you can call it as a 2, A3 and 4, and you just 1 to 2, there is a 2 point AB, and here 2 to 3, one more, so point. So here the distance is, okay, take the arc, so placed here, and 15, cut the arc. So from here same 15, cut the one more arc, and from here this distance, it is of 25.98, cut the arc. Okay, so you can call it as a name. This is A, this one is B, and this one is C. We already know that C is parallel. Okay, so use the line, it's a parallel, and here parallel, of course you can take the compass placed here and 15 mm, take the compass placed here 15 mm, you can cut the arc, but it's an easy method. This one is D, and this one is E, and this one is F. So once we got all the points, use the line, okay, and from A to B, B to C, okay, then D, then E, then closed it. So we constructed, and normal scale, and finally once the construction is over, you directly use the scale, okay, and copy this and go to scaling and convert 0.815, okay, or you can use 0.82, yes, placed it. See, now it is converted to isometric. So previous method is converted and constructed, here normal scale, then converted. You just measure this distance, see, both the distance are same, isometric, clear. Like this also you can construct, okay, and this is pentagon and hexagon. Last one is there, isometric of circle, that I will explain in the next class. Yes, the next object construction is circle, okay. So this is circle, a construction of circle, a 50 mm diameter. So again we can construct a top and front view in isometric. So this construction is what we are going to follow is a 4 center method. It is called a 4 center method, a construction of circle by using a 4 centers. See here, there is a O1 is a center 1, center 2, center 3, center 4. With the help of these 4 centers, we are going to draw the arc. That's why it is become a 4 center method. Clear? And if you see in the normal view, the circle is look like a circle in a 50 mm in the front or top. Okay. But if you see in the isometric, the circle will look like a ellipse. It is not look like a circle, it is look like a ellipse. If we turn that circle in any angle, it will look like a ellipse. Only with respect to the parallel. If you observer parallel to the circle, then only it will look like a circle, exact circle. Clear? Because the major diameter, minor diameter, both are equal in a circle. But in case of ellipse, the major diameter is different, minor diameter is different. Okay, that's why it is look like a ellipse. If you turn that circle to any angle, it will start look like a ellipse. So here we are going to relocate on it onto the 30 degree. So 30 degree, it's an inclination so that it will look like a ellipse. So it's a front view, okay, top view and front view. Okay, I will show you. So first thing, draw a circle of diameter 50. Next, construct a box. That's the most important thing. You should construct a box. For circle also you have to construct the box. Use the scale. Then erase everything. Name it as 1, 2, 3 and 4. And this box is of dimension. So 50. Okay. So now take the line. Draw it. First thing you have to place 30 degree. Similarly, here angle is 30. Sorry, that angle is 150. Then take the arc, same thing. Cut 50. Similarly, 50. Then use the line. It should be parallel to this, and use the line. It should be parallel to this line. Okay. Yes, you can call it as a name. This is 1, a 2, a 3 and 4. So now we have to represent this circle in this box. Okay. So use a 4 center method. First take the line from 1 placed here on a 1 and use the scale exactly on the middle between 3 to 4. Draw a 1 line. Again from 1 to middle between 2 to 3. Similarly from 3 to middle of this 1 to 4. And similarly from 3 to middle of this. Like this you have to draw a 4 lines. That 4 lines will give the 4 center. Okay, you just call it as a, this one is a O1 and this is O2 and this is O3 and this one is O4. So there are 4 centers. And take the arc or your compass, place it on O1, okay, and stretch up to this point and cut the arc. Similarly on a 2, okay, placed here and draw a arc. Similarly place 3 and stretch up to here, okay, then draw a arc. And finally placed on a 4, placed here and draw arc. So like this you have to use a 4 centers to draw the circle. See, so the circle, it will reduces to ellipse, and after constructing use the scale and reduce 0.82. It reduces to isometric. Okay, you just measure this ISO 50 means 41. You just use a calculator. So 50 into 0.82, that gives the 41. So 41 is the actual length, isometric length. So it's the top view. If you want to construct a front view, it's a top view. If you want to construct front view, again use the same line. Okay, and first vertical line draw here, then 30 degree. So if you draw a vertical line, it is become a okay. Next take the arc. So here 50 mm, cut the arc. So placed here, same 50, because the same box. Like this you have to cut the arc. Okay, then use the line. It should be parallel to this line. And after that, you can call it as this as a 1, this as a 2, a 3 and 4, the same box. Okay, and after that use the scale. So here middle of this line to middle of this line, middle of this, middle of this. So you got the 4 arc points. Use next okay, and similarly use the same method. Use the four arcs. See, like this you have to construct. This point is 1, 2, 3, 4. There is a 4 center method. It's a front view, it's a top view. Like this you have to construct. The method is same. Okay, if you draw vertical line, it become a front view. If you draw both 30 degree, it will become a top view. So like this you have to construct, and finally after constructing you have to scale down to isometric 0.82. See, like this, and placed it. Okay. So in this way you have to construct pentagon, hexagon, circle, all the shapes you can convert from normal to isometric scale. So based on this a fundamental, you can constructing a different complicated shape into isometric view. That we will discuss in our next class.